Hope I'm audible. Sorry for the delay. So I'm facing some network issue. That's why it's like.
It's okay, sir.
Okay. So thank you for joining. So let's start for week 7 problem solving. So let's share my screen. So hope this screen is visible.
Yes, sir.
Yeah. Thank you. Okay. So I hope this week the problems are quite easy, so it will not take much time to solve this question. So let's start with one by one. So the first question they are asking is that what is the method for solving word analogy questions like given A, B, D, C such that A equal to B and C equal to D using what vector? Okay. So they are asking ki, so we know there is analogy between A, B and C, D. We know the embeddings for all these things A, B, C, D and all these things. So they just want to know what is the word for C. So how do you find the word C? So let's do this thing. Let's create the frame. I hope you guys know what is word to vec and all these things, because this word to vec are nowadays like it's kind of old, so people nowadays use those things rarely. But still, I hope you also saw this thing. So there is a like from distance from king to man, queen to man, or similar kind of thing. So this question is like that only. So in this question, they are saying ki. So in this question, they are saying ki A is to B equal to C is to D. Okay. So A, C is to B, and the embeddings, like the embeddings for is VA, it's VB, it's BC, and it's B. Okay. Now if they are similar, then the distance between A and B, so the distance between A and B and distance between C and D should be similar. This is capital D. So this should be similar. So we'll use this thing only. So what is the distance between A and B? So it is the vector distance. So vector B minus vector A. So which will be equal to vector D minus vector C. But but the problem is that we need to find the word C. So we need to find the word C. So what is the word? So we know the embeddings, but I want to know the word corresponding to this. So okay, now if we solve this formula, so what will we get? Like then VC, if we just take it here only, so it will be VC equal to VD plus VA minus VB. Okay. Or yeah, so this is the thing. Now we know the embeddings of VC now. Now how will you get the word corresponding to VC? Now you can get it here. So suppose this is your embedding space. Okay, so this is your embedding space. So these are the words in the space. Okay, suppose these are the words. So I just draw it like a 2D embedding plane. So this is the X and this is the Y. So suppose each of the words, suppose A represented by two dimensions. Basically, suppose A is 2, 3, B may be 3, 4, something like that. So maybe A is this, B is this only, C is maybe D is this, and C is maybe this one. Now how do we find like what is the C? Now we can find it like this. We know the embedding. So we know the embeddings means we know the coordinates. We know the coordinates of so basically this is this. So basically this thing is embeddings of VA. This thing is embedding of VD. So similarly, if we know VC, so we know some of the points here. Okay, so we know some of the points. So if we know the points here, then we can find the nearest points from this only. So suppose we just do a kind of Euclidean distance from this point to all these nearest points, all the points, and what will and if we find there is a word corresponding to this point, so that will be C. So basically this is the thing. So I'm just suppose this is the thing. So okay, so I know this is A, I know this is B, I know this is D. Okay, and also I know this is C, but like I need to search it. So and this is the 2D diamond. So suppose each of these words are represented by 2D, like only two dimensions. So now suppose this BC is suppose BC. So this is signed. Suppose BC. Okay, so the thing that we get it from here. So suppose this is BC. So this is BC. Now how do I find? So then what we can do is that, like if in our vocab there are maybe 10 words, suppose in our vocab there are maybe 26 words, suppose in our vocab there are 26 words A to Z. Okay, and each one of them will have their corresponding embeddings with that. So some X I YI, something like that, YI. So each of them have some embeddings with that. Okay. Now I know VC. So what we can do is that, like we will get the distance from BC to X A, BC to some other points, BC to some this point. So each of this point I will find the Euclidean distance, because I know the coordinates. Then I can find the Euclidean distance from BC. And what to like among all these distances, which will be the minimum? That will be the point C. Yeah. So that will be the point C according to this this thing. So suppose for this one, so this point I will calculate the distance from D. I will calculate the distance from B. I will calculate the distance from A. I will calculate the distance from E. And among all these four distances, C is the minimum. So that's why my guess is that BC is corresponding to C only. So this is the corresponding word, like from the analogy. If A equal to B, then for D this is the correct C. So this is the thing. So if we see the thing, so okay. So now let's see what is the answer. Okay, so what we have got, so BC is that VD plus VA minus VB. Okay, so BC is a VD VA minus VB. Okay, so D is there, but what they are showing is that, like VC is VD plus VA minus VB. Till that it is fine, but they are saying then do a dictionary lookup for VC, but this is not correct. So in the dictionary there is it is possible that VC is not corresponding to any legal embedding. Okay, so basically what I am trying to say is that let's see. So I get VC so from this formula. So I get the embeddings of this thing from this only, but what they are saying is now, when I get this thing, then I will look up a dictionary and find the corresponding. So they are saying okay. So if this is a dictionary, in the dictionary this is the embedding and it is corresponding the word. Maybe this is V and this is corresponding to word V. So if this is the dictionary, then we can just search the dictionary and find okay. So this is the embedding for BC. So that then C is the correct word. But what if this number is not in dictionary? Okay, so suppose the thing that I'm showing is, like, suppose the point A is with embedding 2 3 maybe. Okay, so maybe point B is like 3,1, maybe point C is 4,4, maybe point D is like 3,3. So suppose this is the thing. Okay. Now uh, so this is the corresponding word. So so in the dictionary we will get this kind of thing. So a will be 2 comma 3, it is mapped to a. B will be 3 comma 1, it is mapped to b. C will be 4 comma 4, it is mapped to C, and D will be maybe 3 comma 3, it will just. Now suppose when we calculate this kind of thing, we calculate this kind of thing, we got BC equal to something like that, maybe 1 comma 2. Okay, so suppose we get the number is 1 comma 2. Now if we do the simple lookup, in the lookup there are no embeddings for this thing, so 1 comma 2, so we'll never find the corresponding word C. Okay, so what our like how we'll get the word, we need to find the nearest embedding from this thing. Okay, so from this thing we need to find the nearest embedding. So basically if in the dictionary there are multiple embeddings already given, then we need to find the distance from all these things, and which of the embeddings will give us the smallest number, that will be our correct answer. So if this is the diction, and then I will find the distance from this and this and this. Suppose this will give us the smallest distance. So suppose this will give us the smallest distance, then maybe A is the answer. So for this question A is not be the answer, but I guess what I am trying to say. Yeah, so I guess you will you already understand what I am trying to say. So then we'll just do the cosine similarity. So basically cosine this VC comma A, and then again we'll find VC comma B, and so all these things we will find, and among all these things, what will give the minimum, that will be the that portion will be, that word will be our answer. Okay, so but if we see in the options, D is fine, so we'll find the VC, but they are saying do dictionary lookup. But with simple dictionary lookup, it is not possible to find the corresponding word. So the correct option will be none of the above. Okay, the correct option will be none of the above, because till D is the correct option if they don't say that then do dictionary lookup. So if they say okay, so without doing the dictionary lookup, we need to get the distance with VC with each of the element of dictionary, and find the minimum distance embedding. That will be the correct option. But if you see all this option, that is not the correct. Now see, you can see, so this is the same thing. So option C will be the correct option if this part will be correct, because then use cosine symmetry to find the closest word. Yes, this is the correct thing. So then we'll need to find the cosine similarity to find the closest word VC. So combination of C and D is correct, kind of correct, but but not individually. So E is the correct option. None of the above is the correct. So I hope you get the thing. If you have any doubt, you can ask. Or okay, so as no one has any doubt regarding the question, so let's move to the next question. So the question is pretty simple. So the simple numerical type of question. So what is the value of PMI, WI, W2? All these things are given. You just need to calculate the value. I hope you already know this thing. So basically, what is the thing? So what is the formula of this PMI? What is this thing? PMI W1, W2. PMI W1, W2. What is this? If I remember the formula, it is log of probability W1, W2 by probability of W1, probability of W2. So I'm not sure if I have this is the formula only. So probability of P of W1 W2 by probability of P2. Now each of these individual this thing you can get. So what is probability of W1 W2? So all these things are given. So yeah, total so count of this thing are given, total number of n is given. So basically this is the count of W1 W2. So how many times W1 and W2 occur together, and total number of words in your total vocabulary. And similarly PW1 is count of W1 and then n. So this is the probability, and probability of W2 is similar to the count of W2. So if you just plug it into in your original log formula, it will be count of W1 W2 by n and count of W1 by n and count of W2 by n. Now if we do it correctly, it will be log of yeah. So here there are two n's. So here only one n. So one will be, so that will be n into count of W1 W2 by. So you know all these things. So you know n, you know this thing. All these things are given here only. So all these things are given here only. You just need to put and get the answer. Okay. So yeah. So we will be log of n is given like n is given 10 to the power 5. N is given 10 to the power 5. So this is 10 to the power 5. Count of W1 W2 is given 64. So basically this is 64. Count of W1 and W2 is 100 and 200. So in total 2 to the power 10 to the power 5. So 100 into 200. 100 into 200. Oh, 2000. Sorry. 100 into 2000. So basically if we just do it here only, so it will be log of 10 to the power 5 into 64 into 2 into 10 to the power 5. So this 10 to the power 5 will eliminate. So it will be log of 32, because it's these two and these two. So it will be log of 32. Now in the question they are saying ki use base 2. Okay, so so basically this, so they are saying you need to do this thing only. So you need to do this thing only. So now here log 2, this 32 is 2 to the power 5. So according to the formula, it will be 5. Okay, so the answer will be 5. Okay, so answer is 5. Yeah, so the B is the answer. So this is very simple question, just plug and play. So you know the formula of PMI W1 W2, just need to plug all these values are given, you just need to do this. So I don't think for this question anyone has any doubt. Okay, so well and good, let's move to the next question. So again, simple numerical type of question. So given two binary words W1 W2 are given. Now they are saying ki compute dice and J-card similarity. Okay, so for the sake of completion, let's do it. So W1 and W2 is given. So W1 and W2 are given. So W1 is 1 0 1 0 1 0 1 0 1 0 1 0 1 0 5 times 1 0. Okay, so it is 5 times 1 0 1 0 1 0 1 0 1 0 1 0. Now this is 0 0 6 times 1 then 2 0. So basically this is 0 0 6 times 1 then double 0. Now they are saying calculate the dice and J-card. Okay. So dice and J-card. Okay, so what is the formula for dice? It is similar. So basically 2 of, so if, so it will be union of W2 and W1 plus W2. This is the dice thing. And what is the J-card? J-card is intersection by union. So it is intersection by union. Okay. So let's find the values. So let's find the what is the union of these two. So basically, what does this union mean? So how out of this, so how many this two vectors? So what is the dimension? So 1 2 3 4 5 6 7 8 9 10. So these two are 10 dimension vectors. Okay, so these two are 10 dimension vectors. So among these 10 dimensions, how many of them are 1? So if you take the union, so you just need to take the total. So for the first dimension, this is 1, this is 0. So basically on an if you take the union, so this is so if I write it here only, so just write it union here only. So this is also will be 1. This is will be 0 because no 1 is there. This is 1. This is again 1 because if any of the value is 1, then the union will be 1. So this is 1. 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 But last is. So out of these 10 dimensions, 8 are 1. So union of this will be 8. And similarly, we can find the intersection. Okay, so intersection, what is the intersection? So intersection basically if I write it here only, so W1 intersection W2, basically this is the union. So if both of them are 1, so then only union will be intersection will be 1. So for the first dimension it will be 0 because like one of them is 0. So this is also 0, but this will be 1. This will be again 0. This will be 1. This will be again 0, 1, 0, 0, 0. So out of this 10 dimension, only 3 are 1s. So the union of intersection of W1 and W2 will be 3. Similarly, what is W1? So among these 10 dimensions, how many are 1 in W1? So this is 1, 2, 3, 4, 5. So it is 5. Similarly for W2, it is 1, 2, 3, 4, 5, 6. So it is 6. So now just plug the value here, you will get the. So if we calculate the dice, so dice will be 2 into intersection of W1 W2, intersection of W1 W2 is 3, so it is 3, and then mod of W1 plus W2, so it is 5 plus 6. So basically 6 by 11. Now this is the dice, and for J-card it will be intersection of W, it is 3, and union of W1 W2 is 8. So these two are the answers. So dice is 6 by 11 and J-card is 3 by 8. Yeah, so the first one is the correct answer. So yeah, 6 by 11, 3 by 8. 6 by 11, 3 by 8. I hope this is clear. So basically this is very easy. These problems are very easy. If you just follow the formula, and do count it properly, you will get the answer. Okay, I don't know why they give it 2 marks here. Okay, still let's move to the next question. Okay, so next question is like in the following figure 1, P and Q are the two word vectors from the for the word natural and language respectively. Okay, so P is the vector for the word natural, and Q is the vector for language. Now they are saying what will be the resultant vector R for natural language. So basically, this is the vector addition. So there are two vectors result, so they are also saying so resultant word vector are for the natural language after adding the vector P and Q. So this is the class 10 plus 1 physics question. So basically you just need to, so there are two vectors are given, you just need to add the two vectors. So what is the way to add the two vectors? So if you remember, so there is a rule called parallelogram rule. So you just need to add this thing. So what is this thing? So this is the thing. One is Q and one is P. Okay, so this is Q vector and this is P vector. This is P vector. Okay. Now what? So they are asking what is the addition of this thing. So basically P plus natural language. So what is the parallelogram rule? So you just need to draw the parallelogram. So if this is one of the vectors, so just need to draw the parallel same vector here only. So just this thing only. So suppose this is the vector. So for the the space constants, I'm just drawing it small, so it can be like from till here only. Okay. And similarly for P also you need to draw a parallel diagram here. So this is the whole diagram. So the structure is not proper, but I hope you get the point. Now what is the addition of these two? This is basically from one initial, so one initial starting point to the other opposite starting point. So this is the P plus. So this is coming from vector calculus. So vector this class 11 physics. So yeah. So this is the correct answer. This will be the correct answer. So you need to draw the parallel for P vector. You need to draw the parallel for Q vector. So it will form a parallelogram. Then from the initial point, you need to take the diagonal as the resultant vector. Okay. So yeah. So option A is not the correct one because it is out of the scope. Yeah. So the B is the correct answer. Okay. So B is the correct answer. So if you see this is the between this thing, this is going. Option C is not the correct one, and D is like they are saying none of this insufficient data. No. So we have sufficient data to get the addition of this P and Q. Okay. So addition of this P and Q are given. So this is easy. Okay, so for 5, B is the correct answer. Okay, so let's move to the next question. Again, the question is pretty simple. So what is the question? So consider two probability distribution for words P and Q. Compute the similarity score with KL divergence. Okay, but okay, why they are giving two values? Oh, okay, I got it. So because like the KL divergence is not symmetric. Okay, so I hope they are asking to calculate the both ways. So yeah, now I get it. So basically, so they are asking to solve the KL divergence of this is how we write the divergence for this P and Q. Yeah, but the thing is that P and Q are not like P and Q are not necessarily it will be Q P. Okay, so that's why they are giving two values. Okay, so they are giving two values. They are asking to calculate the KL divergence, but from the both the direction. Okay, so so basically we need to calculate two values. So one for this one and one for this one. Okay, so we can calculate the formula only. Someone is coming. Okay. Okay, so what is the formula for KL divergence? So for this one, so it is like if we just write it correctly, it is the summation. So if the P is basically a distribution, so it is a summation of all this value from Ti log. Okay, so it is Pi Qi for all I. So basically, if this is a distribution, then we need to sum over all the points from this distribution. Okay, so this is the KL divergence from between P and Q. Similarly, it will be for opposite like Q between Q and P, it will be summation of I. It will be Qi log Qi Pi. Now all these values are given. You just need to calculate. So P is given. So in the P distribution there are 3 points. So in the P distribution there are 3 points. In the Q distribution there are 3 points. So what are the points? So 0 0.2, 0 0.75, 0 0.50, 2, 7, 5, 5, 0. 0 0.2, 0 0.75, 0 0.5. And for Q it is 9, 1, 2, 5. Okay. 0 0.9, 0 0.1, 0. So here this is 2, 5. So basically so there are 3 points. So let's calculate for this one only. So for the first one it will be 0 0.2 log of 0 0.2 by 0 0.9 plus for the second P. What is the second P? So it is 0 0.75. So it will be 0 0.75 log of 0 0.75 corresponding. What is the Q? It is 0 0.1. So it is 0 0.1 plus the last Q is 0 0.5 log 0 0.5 plus 0 0.2. Okay. So and you just need to calculate all the value and you will get the answer. Here they have said anything. Okay, so they have said use base 2 for logarithm. So yeah, so you know the base set. So this is the base 2. We'll get the value. Similar for Q1, so it will be the first Q is 0 0.9. So it will be 0 0.9 log 2 0 0.9 by 0 0.2 plus 0 0.1 log 2 0 0.1 by 0 0.75 plus 0 0.25 log 2 0 0.25 by 0. You just calculate and you will get the answer here. So this is just a calculation, so I am not doing it. Yeah, so this is the thing. So I hope for question C, yes, if you do it correctly, C is the correct answer. So basically they are saying C is the correct answer. So 2.246 or and 1.1. So you can just calculate and check. So this is just a simple calculation. Log it. So we are not now interested in doing it. Okay. So I hope this is fine. Okay, so there is another question from previous year regarding the scale divergence. So let's solve it here also. So the question is that, like, what is the KL divergence between the following probability distribution? So P and Q are given. So you need, just here, if you see the question 6, so P is given, so there are 3 values, Q is given. So this is also a distribution, so we just here only 3 values are given. Okay, only 3 values are given, and here they are not explicitly not giving the values, but they are saying, okay, so P and Q's are the distribution, and they are represented it with a random variable. So this is the X is a random variable. Okay, so this is the P distribution, and this is the Q distribution. Okay, so now they are asking what is the KL divergence between P and Q. So the thing is simple, but just there is some like, you just need to calculate it properly. So let's do it. So the first, it is 1 by 2 to the power x, and Q is given. It is, what is the Q? Q is given 2 by 3 to the power x. 2 by 3 to the power x. And now they are asking to calculate what is they are asking? They are asking to calculate divergence, KL divergence of P and Q. Okay. So they are asking KL divergence P and Q. Okay. So if you remember the formula correctly, what is the formula? So basically, if this is the formula, will be the summation of P. So this is the probability function. So this is the function. So the probability, this thing, then log probability of x, qx. And what is the value of x? So x, so in the, if you see the question, so x is like for all the this natural number. So this is z plus the natural number. So basically this x is like natural number. So from 1 to infinity. So basically this x is a like small x. Okay, I'm just ignoring this thing. So this is the total functions. Okay, so this is the thing. Now you just need to just put the value and find the divergence. Now if you just do it like this, is x equal to 1 to infinity, and what is the px? Px is 1 by 2 to the power x, and it here it is 1 by 2 to the power x by 2 by 3 to the power x. Okay. Okay. Now if you do it correctly, so it will be summation x. So basically this is just a calculation thing. So 1 by 2 to the power x, and if you just do it, so what will be this thing? It will be log of, just change the thing. So it will be 3 to the power x. Okay, 3 to the power x by 2 to the power x into 2. So this is 2. So this is the whole thing. So if you just format it, it will be. Now if you just write it carefully, so I'm not writing this x1 to infinity again and again. Just this is the thing. So I'm just writing it to x. It will be log of, if we just write it 3 by 2 to the power x into 1 by 2. You can just write it here this way. Now what is the formula? Now this is the log of a multiplication. So what is the formula? So log of AB, basically log A plus log B. So you can apply it here only. So it will be summation 1 by 2 to the power x log of 3 by 2 to the power x, sorry, 3 by 2 to the power x plus log of 1 by 2. Yeah. Okay. Now what you can do is that, like, I'm just writing it here. Now just multiply it with this thing. So it will be, what will be the first term? First term will be summation 1 by 2 to the power x, okay, log 3 by 2 to the power x plus, so this is the whole thing. It will be 1 by 2 to the power x log up. Okay. Now you know, so this is, you can put this x here only. So this is the power, so log of this power will, you can take it in front. So it will be x by 2 to the power x log of 3 by 2, okay, plus this will remain same as. Now just let's do it here only. So just move this summation inside, like for each individual of this. So let's put the summation. So what will be the first summation? First summation will be summation x 2 to the power x log of 3 by 2 plus summation 1 by 2 to the power x log 1 by 2. Now in this summation this thing is constant, so we can take it outside. So it will be log of 3 by 2 summation x by 2 to the power x. Similarly for this one, this is for this summation, this is constant, so we can take it outside. It will be log of 1 by 2 summation 1 by 2x. So now we have two terms. So one is this term, another is this term. Now we just need to calculate the summation for this summation and this summation. So what are the different summations? I'm just writing it here. Okay. Okay. So the first summation is summation of, so if we just write it individually, this is x by 2 to the power x. So x is 1 to infinity, and another summation is summation x is 1 to infinity 1 to the power 2 to the power x. Now this summation is pretty easy. Now this is like, so what is this? This is a infinite GP series. So 1 by 2 so this is 1 by 2 plus 1 by, so this is the GP series, 1 by 2 1 by 4 plus 1 by 8 dot till infinity. So what is the summation of this GP series? So if we just recall the engineering mathematics, so whatever this, so this is this GP series where the common ratio is, what is the common ratio here? Common ratio is like, this is the common ratio. So each time we are just multiplying with 1 by 2. So this is the common ratio. So R, so common ratio is R. So R is 1 by 2, which is less than 1. So basically this is the formula. So then it will be, so basically in such type of GP series, so if this is the thing, so a r to the power 0 plus a r to the power 1, so whatever this thing, so the formula is a by 1 minus r. Okay, so if you just remember the formula, just check the formula. So what is the A is the first term and R is the common term. So here what is the first term? So first term is 1 by 2. What is the common term? It is also 1 by 2. So it is 1 by 2 by 1 by 2. So it is 1. So this summation is 1. So this summation is 1. Now what is this summation? So this is, if you just see it correctly, it's a combination of arithmetic series and a GP series. So this term, so this x term, so this x term is a arithmetic series. So each time we are just incrementing with a like normal. So arithmetic series, so 1, then 2, then 3, then 4. But this 2 by x, it's a GP series. So as a whole, this is a arithmetic geometric series. So this is just a formula. So if you just check it correctly, so this is just a combination of, so this is a combination of a AP and GP. So this is a combination of a multiplication of AP and GP. So each term of this series is a multiplication of a AP and corresponding GP. So what is the AP term? AP term is like this x, and GP term is 2 to the power 1 by 2 to the power x. So this is a multiplication of this. So basically this type of series is called arithmetic GP series. So AGP is a kind of thing. So if you just check it, though, this the formula of this is R by 1 minus R square, like this. So what is the R? R here is the common factor. So the common factor is 1 by 2. So each time is incrementing, so it's 1 by 2. So if we just put the R by 2, it will be 1 by 2 by 1 minus 1 by 2 whole square. So it will be 1 by 2 by 1 by 4. So it will be 2. So thus this AP, so this series is 2. Now we can just put the result here. So this is 2 and this is 1. So basically as a whole the sum will be 2 log 3 by 2 plus log 1 by 2. So the whole problem is like kind of calculation. So you just need to know different series and how to calculate this is all about this. So this is the final result, 2 log 3 by 2 plus 1 by 2. Yeah, so number 3 is the correct answer. So log 1 by 2 plus log 3 by 2. So like it's looking like kind of messy, but if you just follow the steps, so basically you just need to know the KL divergence formula, and then if such kind of series are there, you just need to know what is the series and what is the some rule of to solve this thing. So this is kind of 1 by 2 to the power x. It is quite common. It is a GP series, but this kind of arithmetic and GP, the common thing, is not that quite common. So I hope this type of problem will not come into your final program, but still it's always better to know this kind of expressions. Okay, so I hope this is okay. Let's move to the next question. So the question is that so the co-occurrence matrix is given, and so they are asking to compute the cosine similarity between W1 and W2 and W3 and W4. Again, it's a easy problem. So this week all these things are pretty easy. So the co-occurrence matrix are given, cosine, then you just need to calculate the cosine similarity between W1, W2 and W1 and W3. So let's do it. So what is the matrix? W1, W2, W3, W1, W2, W3, 2 1 3 9. Okay, sorry, 2 1 3 9 5 0 4 6 1. So basically just ignore this one. So these are maybe you can consider it as dimension 1, dimension 2 or something like that. So they are thinking this is co-occurrence matrix, so I'm just writing it W1 W2. So in the question they are writing it as W4 W5. So it's not mattered much, but still this is the matrix 213950461. Now there is cosine similarity between W1 W2 W1 W3. So basically they are asking cosine similarity between W1 W2 and cosine similarity between W1 W2. So what is the formula for cosine similarity? So the formula is like, what is the formula? So cosine similarity or between two vectors, so W1 W2. So the dot product. So this is the dot product, and then this modulus of this. So this is the formula. So basically, yeah. So basically they put it in the double bracket. So, yeah. So this is the formula. So what is the W1 vector? So W1 vector is basically, this is the W1 vector. Basically you can think of this is the dimension 1, this is the dimension 2, this is the dimension 3. So basically a 3-dimensional vector. So similarly W2 is a 3-dimensional vector. So let's calculate the first one. So it will be 2, 9, 4 dot 1, 5, 6. And what is this thing? So how to calculate the modulus of vector? So basically it is a root over of each of these elements. So what is the, so if this is a vector, suppose this is a vector, so a, just write it here, I hat plus b j hat plus c k hat. So suppose this is a vector, so this, all these are unit vector on this particular dimension. So the modulus of this thing will be root over a square plus b square c square. Okay. So this is the modulus of this. And similarly, then this will be 2 to the power 2 square plus 9 square plus 4 square. So it will be root over 1 square plus 5 square plus 6 square. And what is the dot product between two vectors? So it's a element wise multiplication. So this 2 will multiply with 1 plus this 9 will multiply with 5 plus this 4 will multiply with 6. So element wise multiplication. So we need to multiply the element with corresponding the counterpart of the other vectors. So it will be 4 into 6. Just can now calculate the value. So what is the value? So it is 81 plus 4 plus 16. So 20. So what is the value? So it will be 20, 101. So it will be root over 101. It will be root over 100, 1, 25, 36. Okay, so it will be, just calculate, so it will be 2 plus 45 plus 24 plus root over this 101 and if you do the calculation you will get the value. So you will get the value. So what is, yeah. So if you have calculator, you can just solve it and get the value. And similarly for this one also you can do it. So basically it will be like between 294 and what is W3? W3 is this one, 301. So dot or 301 and then root over, we already know this is 101, so this is 101 and it will be root over 3 square 0 square 1 square, so it will be 9 plus 1 10 and dot product. If we do that thing, so it will be 6 plus 0 plus 4 and root over 101 into root over 10. So it will be root over, so it will be 10 by root over 100. So basically root over 10 by root over 101. Okay. So this is the, if you have calculated, you just calculate the value. Okay. So I don't know is it a correct. So let's calculate the value only, so to check it. So it will be, let me calculate it. 10 by 101. 10 by 101. Oh, I don't know. So just calculate the value. So I am not sure what is the correct answer here. So I don't have. Maybe yeah, 0.33. Yeah. So maybe D will be the correct answer, because if we see, so this is coming, if we divide 10 by 101, it will coming 0.099. so I'm just seeing 3 here only, so maybe this is the correct answer. Number 3 is the correct answer, maybe. So 0.315 into 0.315. Yeah, and number D. So D is the correct answer. We just calculate the thing, we will get that. So D is the correct answer. Yeah, so that's it for this week. So I don't have any further question to discuss, because this week all these problems are pretty easy, basically numerical problems, simple plug and play. So if you know the formula, just take the value and put into formula, you will get the answer. So there's nothing much to discuss for this week only. But still, if you have any doubt about this embedding things, so how they work and all these things, you can ask. I'll try to clarify, or else we'll stop what you will say. So I hope you don't have any further doubts. If anyone has any doubt, they can ask, or else we can close it.
No doubts. Nothing. Thank you.
Thank you very much. Thank you. So thank you. So let's drop. We'll meet again next week. Till then, goodbye. Thank you, everyone.